This educational virtual exhibit is titled Bloede Dam 1907, Patapsco River, Avalon, Maryland. A black and white photo of the downstream straight-on view of the watered dam is captioned Bloede Dam 2016. Photo by Jerib Ortiz, HDP photographer. A warning in red states the images in this video may cause motion sickness. Viewer discretion advised. Two black and white photographs of the dam fade in, the first captioned Bloede Dam 1907, Baltimore County Public Library, and the second captioned Bloede Dam 2016, photo by Jerib Ortiz, HDP photographer. American Rivers, in partnership with the Maryland Department of Natural Resources, Maryland Historical Trust, National Oceanic and Atmospheric Administration's Restoration Center, and U.S. Fish and Wildlife Service, sponsored the Bloede Dam recording project with the historic American engineering record in 2016. The dam was demolished as part of a larger project to restore the river flow of the Patapsco River and is the third dam to be removed. Union Dam and Simpkins Dam were previously removed in 2010. The dams on the Patapsco River have been determined to block the river flow, prevent fish migration, and pose public safety threats. We begin with an aerial view of a 3D laser-scanned point cloud showing the downstream side of the dam and its lush landscape while panning counterclockwise around the structure. The Patapsco Electric and Manufacturing Company contracted Amberson Hydraulic Construction Company to build a dam and powerhouse on the Patapsco River. Completed in 1907, Bloede Dam was constructed following Nils F. Amberson's patented design to supply power to new suburban developments around Catonsville, Maryland. The reinforced concrete flat slab buttress dam had an open interior in which the powerhouse with its two turbines was located. This unusual arrangement was the first of its kind. We continue to pan around the dam. In addition to its engineering significance, Bloede Dam is also significant for its association with Victor G. Bloede (1849–1937), chemist, manufacturer, and founder of the Patapsco Electric and Manufacturing Company. Bloede held a number of patents for his innovations in glues and dyes, including a patented process for producing color-fast dyes. In 1885, he established Victor G. Bloede Company in Baltimore, which was perhaps best known as the sole supplier of postage gum to the Bureau of Engraving and Printing in the 20th century. As we begin to descend closer to the downstream side of the dam, water cascading over the dam fades away, revealing the flared, deteriorated, concrete spillway or apron. The tops of the trees and the spillway then fade away, revealing the internal concrete base of the dam composed of sloping buttress walls with ceilings that meet at a blunt peak. As we move across 14 bay enclosures to the other side of the dam, the camera pauses. By 1932, Consolidated Gas Electric Light and Power Company had assumed ownership of the dam and determined it was no longer cost-effective to continue operating the powerhouse at the site. The equipment was subsequently removed, but the dam remained in place without any significant alterations. Hurricane Agnes and subsequent flooding resulted in the loss of the two motor houses on top of the dam and significant damage to the original wooden fish ladder in 1972. Stabilization and repairs were completed in the early 1990s, including construction of a new concrete denial fish ladder. We pivot our view 180 degrees to view the fish ladder and pause. In 1992, the replacement fish ladder was erected on the south abutment. The state chose to build a concrete denial fish ladder with wood baffles, because of its ability to provide a continuous stream of low-velocity water to the fish so that they can ascend the fishway and exit above the dam or blockage to access the upstream habitat. Now, following the concrete chute covered with grading up to the crest of the dam, we fly up and back to an aerial view of the site and then begin a descent toward the south abutment of the dam, between two buttresses, and through a metal doorway. We travel through the dam's interior corridor connecting each bay, revealing their rectangular plan with a tremendous amount of silt covering the floor. The reinforced concrete walls are covered with colorful spray-painted graffiti. We pause in one bay while a drawing and text fade in. The drawing is captioned Measured Drawing of Section Through Dam. Drawing delineated by L. Naomi Doddington. This drawing shows a section through the dam at the now inactive sluice gate intake valves where turbines were once located. Rectangular openings in the downstream wall just below the spillway along with porthole windows in the central bays provided natural light to illuminate the dam's interior. We begin moving down the corridor again, showing each bay with their openings and accumulation of silt. We look left to the upstream side of the bay, and then right to the downstream side, while viewing the sloped walls connecting at a blunt peak above, along with more colorful graffiti at a height just within arm's reach. The original 1907 bays were approximately 10 feet wide, by 27 feet long, and had buttress walls that were typically 1.5 feet wide. The existing 1990 dam repairs added overlay buttresses, that decreased the width of each bay to approximately 8.5 feet, and increased the width of the buttress walls to approximately 3.5 feet. The additional buttress stabilization reduced the width of the openings between each bay from approximately 18 feet, to 4 feet. As we exit through a doorway on the north side, we fly up and over the north abutment to the backside or upstream side of the dam and descend close to the concrete bays as the point cloud model is sequentially sliced horizontally down from the top, revealing the interior plan of the dam. We pause as a drawing, historical photographs, and text fade in. The drawing captioned measured isometric cutaway drawing of dam, 1913. Drawing delineated by L. Naomi Doddington. This drawing visualizes the 1913 structure with its two sluice gate motor houses and revealing one of its two 30-inch Sampson turbines and Alice Chalmers generators within. The timber chute of the original fish ladder facilitated the movement of fish upstream and opened at the crest of the dam. The first black and white historical photo is captioned post-1915 photo of motor houses from downstream view. Baltimore County Public Library. The second black and white historical photo is captioned pre-1915 photo of the 34-inch pool and hunt level wheels and the 30-inch Sampson turbines. Baltimore County Public Library. A different drawing and text fade in. The drawing is captioned measured isometric cutaway drawing of dam, 2016. Drawing delineated by L. Naomi Doddington. This drawing visualizes the 2016 structure before its demolition, revealing sluice gates, now blocked with concrete bulkheads, and additional overlay buttresses to increase stability against higher sediment loads. The concrete denial fish ladder and its wooden baffles allowed fish to easily ascend the chute. We continue to move down the upstream face of the bays to the south abutment while the sliced point cloud model is regenerated from the bottom up. We then zoom around the south abutment to the downstream side of the dam and pan to an aerial view of the entire site with all of the point cloud model restored to show the dam with water flowing over it and its lush vegetation. A black and white photograph shows water flowing over the crest and crashing on rocks below. A crane perches on a rock just right of center. The photo is captioned 2016 perspective view of dam looking southwest. Photo by Jerib Ortiz, HDP photographer. Ending credits are titled Hair, Historic American Engineering Record along with the National Park Service's arrowhead logo. The National Park Service's Historic American Engineering Record, a division of the Heritage Documentation Programs, created this video as part of our workflow progression from raw scan data to the development of measured and interpretive drawings to the Secretary of the Interior's Standard for Architectural and Engineering Documentation, to be included in the Hab/Hair/Halls collection at the Library of Congress. This animation was produced as an interpretive feature created from data captured by a high-definition laser scanner and panoramic photography. The Historic American Engineering Record, HAIR, undertook the documentation in 2016 under the direction of Richard O'Connor, Chief. The recording team included Christopher Marston, HAIR architect and project leader, L. Naomi Doddington, Jeremy Morrow, Ryan Pierce, and Dana Lockett, architects, Justine Christensen, historian, and Jerib Ortiz, photographer. Video created by Dana Lockett, HAIR architect, 2021. The Bloede Dam removal project would not have been possible without the participation and support of the following organizations. The organizational logos include American Rivers, the Coca-Cola Foundation, Keurig Dr. Pepper, Maryland Park Service, U.S. Fish and Wildlife Service, Maryland Department of Natural Resources, National Fish and Wildlife Foundation, U.S. Department of the Interior, National Oceanic and Atmospheric Administration, and the National Park Service.